Okay, well, thank you very much. Thank you for inviting me to do this. We're going to talk about some 19C new features. Every presentation has a her, my slide. This is mine. I specialize in performance tuning, anything related to performance in the Oracle database, and I write about it, and you can read about it at these websites. I have a blog about Oracle. I've spent a lot of my time working with PeopleSoft, and there's a blog about PeopleSoft, and there's a book about what happens when those two worlds collide. I'm a member of the Oak Table, which basically means that we try to apply the scientific method to all aspects of Oracle administration and performance of the database in particular. And I'm an ACE director, which means that I share quite a lot of what I find on the web and in presentations like this. So anything to do with performance is of interest to me. So these two new features in Oracle 19C are also of interest to me. I'm going to say right up front that real-time stats and high-frequency automatic stats collection are only available on engineered systems. I think they're primarily aimed at the autonomous database. They're all part of Oracle's self-managing, self-driving story. Autonomous is built on Exadata, and therefore it's available on other Exadata platforms. It's a pity it's not available more widely. Both of these features are really about helping to provide accurate, up-to-date information to the optimizer. And that is equally applicable on Exadata and non-Exadata. The optimizer has been with us a very long time. It first saw it was first there in Oracle 2.3, long before I touched Oracle in the 1970s. And back then it was a rule-based optimizer. And essentially it did static analysis of your SQL statement, applied a set of, I think, 14 hierarchical rules, which determined whether it was going to use an index, and if so, which one. The cost-based optimizer made its appearance in Oracle 7, around about 1992. And this is what we're now familiar with and have had ever since. The database collected volumetric statistics about the tables and the indexes, and they inform a mathematical model that costs different execution plans and finds the cheapest. That's a bit of a simplification, but that's essentially what's going on. There's an implicit assumption in all of that that the execution plan cost is proportional to the time it takes to execute that plan. And therefore, by picking the cheapest plan, it will pick the plan that takes the least time to execute. It is certainly true that if you don't provide accurate statistics to the optimizer, you can't really expect it to get the right answer. However, it's also true that sometimes even if you do provide accurate stats, you still don't get the right answer, but that's a different presentation. Throughout the history of the cost-based optimizer, there is a continuous effort from Oracle to provide better statistics to the optimizer mathematical model. We've had DBMS stats replace the analyze command. There's lots of automatic behavior that's appeared in the database. We've got histograms to deal with skewed data. We've got a maintenance window to collect stats automatically overnight. We've seen dynamic sampling come in for when you don't have stats or when it can get better stats for you. We've got declarative management of statistics with statistics preferences. We've seen cardinality feedback evolve into adaptive plans so that collection of statistics based upon what it actually finds as it executes the statement makes a difference. We've seen little improvements to the way statistics are collected, like the hash-based number of distinct values optimization in 12C. So Oracle have spent a lot of time ever since the introduction of the cost-based optimizer, putting a lot of effort into providing it with better numbers so it can do a better job. And these two new features, which I'm going to talk about today, are actually just the latest iterations of that progression. Now, because I've been working with Oracle for a while, I remember going to see presentations by the great Dave Enser, who was described by no less than Jonathan Lewis as the grand old man of Oracle optimization methodology. And there is a paradox in statistics collection, which Dave is credited with pointing out, and it is known by some as the Enser paradox. And what Dave said is that the only time when it is safe to gather statistics is when to do so would make no difference. Now, what he's really asking is, what happens when you gather statistics? Well, the plan might change because you have new statistics. But then again, it might not change. And what happens if you don't gather statistics? Well, the plan might still change because the data has changed, or more likely, the literal and bind variables inside the application have moved outside the range of column statistics that are on the table, or into a region where the data is skewed differently, perhaps. So why do we optimize the stats? Why do we spend so much effort making sure they're up to date? Well, mostly so that the plans remain the same. To deal so that the statistics keep up with the changing data and the changing literal values in your queries. And real-time statistics is part of this effort. So this is what the documentation says about it. They are aimed at reducing the possibility of the optimizer making a bad decision because it has out-of-date statistics that no longer reflect the data. We first saw this introduced in 12C for things like create table as select, or for the first direct path insert into a new segment. And in 19C, we now have a feature which extends this to ordinary conventional path DML. Of course, the create table as select collects statistics on non-Exadata as well as Exadata. And the reason for doing this is because stats can go stale as an application comes along and updates the table. So we get better plans that better reflect the data as it changes. The other key point is that real-time statistics are there to augment existing statistics. They're not a replacement. They are built on top of the existing stats that are collected by the DBMS stats job. So everything that you do to collect stats, either through the application, through running DBMS stats, or just running the maintenance window, that still has to carry on. And DBMS stat and real-time stats are built on top of that. As far as I can tell, they're built on the same mechanism that does table monitoring. Now, table monitoring was introduced in 10G, and it's been there by default since 11G. It's the thing that determines, that counts in memory how many updates to a table there have been, or whether you've truncated it, and therefore determines whether statistics on a table are stale. And if they are stale, well, that's what drives stats collection in the maintenance window. And periodically, that information in memory is persisted to disk roughly every 15 minutes. But if you can't wait, you can flush it out with DBMS stats flush database monitoring info. So what happens when you submit a DML? Well, you can't find a call to DBMS stats in the trace. You will find an optimizer stats gathering operation in the execution plan. And then what that is doing is it's tracking the changes to the table in memory and updating the stats in memory, and periodically they are flushed along with the table monitoring information out to the data dictionary where they're persisted in data dictionary tables. And you can view them through DBA tab statistics and DBA tab cold statistics. And what you get in there are additional rows with a note on them to say stats on conventional DML. That means they're real-time stats. Now, I've had a look at this in Oracle 20 as well. And what's been said there by some people from within Oracle is that, real-time stats is going to need a public API, so it can be enabled or disabled. They don't want to control it with an optimizer parameter, because on the autonomous database you can't set parameters. That's part of the deal. So in 19C, real-time stats are enabled by default, but in 20, now remember 20 is only a preview release, so all bets are off. You can't hold Oracle to account over this yet. In 20, there is a parameter to turn real-time stats on, which is currently defaults to false. And you can turn it on at database level, system level, and you can even disable this at session level. I don't think that's the final form, but I do expect some form of API, PL/SQL API, to become available. And you may discover that in 20 that it's not on by default, whereas in 19 you get used to it being there by default. So what I'm going to do over the next few slides is show you a few little test examples, very simple test examples with real-time stats to show you what effect it has on the calculations done by the optimizer. Because if the optimizer gets the calculations wrong in an early part of a plan, of course, that could flow into making a different decision later on in a more complex plan. But I'm going to look at some very simple single table examples. And I hope this is going to show you some of the behavior of real-time stats and suggest some of the limitations and risks that you can fall into. And where you might, and where it does work properly, and where you might want to think about, or where you might worry about what happens. I notice there are some questions coming in, but I'm going to pick them up at the end. So, simple example. I'm going to build a table. It's going to have 3 columns. Column A has got a nice linear distribution. Column A2 has a very skewed distribution because it's built on a square root function. So 1,000 rows, but it's only in the range 1 to 32. And then I'm going to add another 10,000 rows, and it's only going to be in the range 1 to 105. And sometimes I'll commit the data, and sometimes I'll collect stats explicitly, and sometimes I will flush the table, the monitoring information, because I'm not prepared to wait for it to flush automatically. So here you can see an insert statement, and it shows you that optimizer stats gathering was performed. So that's it, gathering stats and putting it into memory. And then I'm going to, after each of the tests, I'm going to query these 4 views, and you can see the stats on the various dynamic performance views. In this case, there are no stats, and therefore that there are no real-time stats, because if you don't have proper stats, you don't get real-time stats, because they are an augmentation of normal statistics. So just because they're gathered doesn't mean they're stored. So this time, I'm going to do the first insert into the table in direct path mode, and I'm going to commit it because I have to commit it before I do a conventional path insert, and then I'm going to insert the next 10,000 rows. And you can see that I got proper statistics, and you can see that I have real-time column statistics, but I don't have real-time table statistics. So I've just got ordinary statistics up here on my table, 1,000 rows. You can see my stats on load, because that was real-time stats collection on direct path insert. So it has a comment on it, and it shows I have 1,000 rows. And then in here in the box, it says real-time stats, and I've got, I actually inserted another 10,000 rows. It's picked up that the range is up to 10,982. It's not perfect. It doesn't gather every insert. It sort of samples it, but it's approximately right. The range is actually 1 to 11,000. I didn't flush the monitoring information. Therefore, I don't get table stats, but I do get index stats, so column stats rather. If I now query, count the number of rows where A2 is less than 42, I get a note on my execution plan. It says, you used real-time stats, stats for conventional DML used. And it estimates 425 rows. Why? Well, the column stats are telling the optimizer that the columns are in the range 1 to 105, but the table stats are saying that it's only 1,000 rows. So 42 over 105 times 1,000 plus a couple gives you, at a bit of rounding, gives you about 425. That's not a bad estimate on that basis, but it's an underestimate compared to what's actually out there. It actually got 1,764 rows. So that's wrong because the column stats are up to date, but the table stats are not. Now I could wait for the monitoring information to flush out naturally, or I could force it. And now I have table stats, which say you've got 11,000 rows in there as well. And I now do the same query. By the way, I've had to put a comment in there, so it's a different SQL ID, which tells you that real-time stats does not invalidate cursors. But I forced it to reparse, and now I still get my note saying real-time stats. And now it says, oh, well, you've got 4680 rows. Why 4680? Well, it's 42 over 105 times 11,000 plus a bit of plus 1 or 2. It's still not right, it's still off, but now it's above the estimate, above the actual of 1746. So now you can see that there's 2 or 3 states we go through. Ordinary stats, with column and table stats. And each of them produce different behaviors. So real-time column stats really are real-time because they're immediately visible. Real-time table stats wait for the table monitoring to flush. Real-time stats do not invalidate cursors, so you may have to wait for the SQL to reparse if you've got shareable SQL. It depends on your application. And we've had underestimates and overestimates depending on which stats are present. Okay, so this time I'm going to populate my table with 1,000 rows. I'm going to explicitly collect statistics, and I'm going to collect a histogram on the skewed column A2. And then I'm going to insert my next 10,000 rows. So you can see there are my real-time stats on the column, on the column, but I haven't got them on the table. And you can see I've got my frequency histogram saying that there are 32 distinct values in the range 1 to 32. So I've got 32 buckets in my histogram. What happens when I do my count? Well, I used real-time stats, and it says I've got 1,000 rows. Why does it say I've got 1,000 rows? Well, because all of the buckets are less than 42. So the optimizer says all of the buckets are in range, so I will query all of the rows in all of the buckets. That's 100% of the table, and I have 1,000 rows in the table. What's happened here is that the histogram has taken precedence over the column stats. That is normal in Oracle, whether you've got real-time stats or not. But because the column stats, so the real-time stats haven't really had any effect here, even though the note says that they have. So I'll flush the monitoring information. I've now got my table stats. It says there are 11,000 rows. Everything else on the screen is as it was before. Run the same query, force it to reparse. Yes, I'm using real-time stats. I've now got 11,000 rows. It's the same reason. All of the buckets are in range. The buckets were only calculated on the original 1,000 rows, but the real-time stats say you've got 11,000 rows in the table, so the optimizer expects 100% of 11,000 rows. It's a bit of an overestimate this time. Even though real-time stats does recognize that the max value on the column is 105, and 105, of course, is greater than 42. It's absolutely normal that histograms take precedence over columns. So what this sort of shows us is that heavily skewed data may still trip up real-time stats. Just while I'm on the subject of histograms and skew, if I'm collecting stats on direct path load, there's an undocumented parameter, optimizer gather stats on load hist, and that says, well, when I'm collecting stats during an insert in direct path mode, I'll also collect histograms. It's an undocumented parameter, but last time I looked, it was set in the autonomous data warehouse, so that when I do an insert append on autonomous, I'll also get histograms as well as table stats. And then while I'm at it, another parameter, again, also set in autonomous, is optimize the gather stats on all loads. And what this means is that anytime you do a direct path insert, not just the first direct path insert into a new segment. So if I do 2 or 3 direct path inserts into the same segment, it will collect stats on every one of them. You may or may not want that. It depends, but it's only set in autonomous. Technically, it's not supported on other databases. So this all starts to raise the question, particularly when we use real-time stats, should we collect histograms by default? And this is a debate that has run for some years, and it depends who you ask. The official Oracle line, as described by Maria Colgan, and I've seen her do it in real life, and you can look up this presentation on the web. The official Oracle position is that histograms are collected automatically for all columns. If you find a situation where you don't want a histogram, then you should set a table preference to say, for this column, size 1, disable histogram collection. The alternative point of view, and I've seen Jonathan Lewis discuss this, is don't gather histograms unless they are frequency or top frequency histograms. Certainly don't gather height balance histograms. Get rid of all size repeat in 12C, which is another separate problem. And he goes further. He says, well, actually, don't collect histograms by default. So change the global preference for method opt for all column size 1. But where you can identify columns where a histogram would benefit you, create a table preference to create a histogram on that column. And where you've got really unusual column distributions, write your own histogram with DBMS stats calls. And you'll see a paper where Jonathan puts that forward. I'm not going to adjudicate through these 2 points of view, but what both of them say is you have to think carefully about the decision to either collect or not collect a histogram. It depends on your situation. Histograms have always, skew has always been the problem, has always been at the root of many performance problems and can trip the optimizer up. There is no one answer to it. Just to complete the discussion of histograms, what happens if I collect proper histograms, proper statistics at the end of my test? So I shall put my 11,000 rows in and I shall flush the data and I will collect histogram statistics and I'll specify histogram on my column. And what do I get? I get bare statistics. I don't get any real-time stats. And the point is, as soon as you collect statistics explicitly with DBMS stats and you replace the statistics that were there, it also gets rid of the real-time stats. There's no point having these augmented stats if your normal stats are up to date. And here you are, I've just got normal stats. And when I query the table, when I've got my up-to-date normal stats, oh look, the estimate's 1765 and the actual 1764, that's pretty good. And that's because the histograms are right and the volumes are all right. So you get the right answer. One of the other things I found is that lone deletes are not tracked by real-time stats. So I'm going to populate my table and then I'm going to delete where A greater than 800 and I'll flush it. And I don't have any real-time stats. They're just not tracked. But updates are tracked. So here I'm going to update columns A2 and B for half of my table, for 500 out of my 1,000 rows, and I'll flush my data. And I get augmented table stats. Still got 1,000 rows. Note that the number of blocks has gone up from 5 to 7 because I've updated some of the rows to make the characters longer. So I have used more data blocks. And I've got 2 new real-time column statistics because I updated 2 out of my 3 columns, and it's detected an increase in the maximum value of that column from 32 to 37. Notice that the minimum value is still 1. You can't detect an increase in minimum value or a decrease in maximum value without scanning the whole table. So real-time stats can't do that. It can only pick up a widening in the number, a widening in the min-max values, not a narrowing. If I do an update, then a delete, that is tracked by real-time stats. And you can see it's now said, oh, you're down to 800 rows. So that's correct. It did find the delete. Of course, the range is still 1 to 37 because the update widened it, even though I then deleted all of the rows at the top of the table. And I've only got 2 rows because column A was never updated. And if I do my query after I've done my update and then delete, it tells me I'm using real-time stats. So why did it estimate 160 rows? Well, A greater than 800 is 20% of the range, 1 to 1,000. But the number of rows is down to 800. 20% of 800 is 160. It doesn't realize that those rows have been deleted. So it estimates 160, whereas it actually returns none. So you can trip it up. If I truncate data, it doesn't remove statistics. That has always been the case. Truncate doesn't remove normal statistics. It doesn't remove real-time stats either. So I'm going to truncate my table, repopulate it, and now my table stats correctly say I've got 10,000 rows. That's absolutely right. And I've got my new ranges. But of course now, if I query it, A less than 500, doesn't quite get that right. It estimates 500 rows because it knows there's 10,000 rows, but it thinks the range is up to 11,000. Close, but not quite right. I think the fact that deletes are not tracked by real-time stats is a bug. the documentation actually says only inserts and updates are tracked. It doesn't claim that deletes are tracked, although deletes after updates are tracked. I think that's a little bit of an inconsistency. It's perfectly normal that truncate doesn't delete statistics, and you can argue about whether that makes sense or not. But you can get yourself into a situation where, having truncated data, you have a mixture of real-time stats on the new data and conventional stats on the data that has since been truncated. So you can get an inconsistency. Now, I've been a little bit mean with real-time stats because I've shown you all of the places where it falls over first. I haven't shown you the thing that it was absolutely designed to do and that it does absolutely well. And this is the problem that real-time statistics is really trying to fix. It's about when a column range goes outside a value goes outside the range of a column on a uniform distribution. So I'm going to populate my table with 1,000 rows, and I'm going to count number of rows greater than 900. And then I'm going to pop another 1,000 rows in there, and I'm going to look for greater than 1,900. And then, just to show you that it's done a good job, I'm going to collect stats and do that query again. So first time round, estimates 100 rows, gets 100 rows, 101 rows. Absolutely right. We have real-time stats saying I've now got 2,000 rows in my table and my range has shifted. Due to the sampling, it's actually said the max value is 1984 when it's actually 2,000. It's not too bad, it's close enough. I'm using real-time stats. It's a little bit off, isn't it? So it said I'm expecting 87, it's actually got 101. It's a good estimate, and this is what real-time stats is there to solve, and it does it very well. Of course, if I have absolutely accurate statistics, it says, well, I expect 101 and I get 101. And that little change actually made it switch from a full scan to an index lookup. So it's good, but it's not absolutely perfect, but it's probably better than not having real-time stats at all. You can't have real-time stats on global temporary tables. It's just not a concept that fits. But you can instead have session private parameters in 11G, sorry, in 12, but you have to collect them. If you lock stats on a table, well, you won't get real-time stats. So I'm going to lock them after I've done the insert and append. And I do have the stats that were collected during the insert append, but I don't have real-time stats. And locking stats really means that you take responsibility for stats on the table. Either you don't want any stats because you're going to use dynamic sampling, or because you're going to manage collection of them manually, perhaps during the application. And I think the point is that no point confusing the issue with real-time stats. You can disable it. It's a couple of underscore parameters, of course not documented, where you can disable stats collection, or you can disable the use of the stats. And there's a parameter, a hint introduced in 12.1, no gather optimize the stats, and that controls the direct path collection in 12.1, but it also extends to real-time stats. In 19, it will control real-time stats collection on conventional DML. But turning it on with the gather optimize the stats hint does not override turning it off with the underscore parameter. It's an unusual case of the specific does not override the generic. One thing I think is a pity is that there's no table statistic preference for real-time stats. I think it would be nice to be able to set a preference saying I do want real-time stats on this table and I don't want it on that table. But that's not what you can do. You have to do it at statement level or session level or database level. So the no gather optimizer stats hint will suppress the direct path. Here I'm going to suppress direct path stats on direct path. So I didn't get stats at all, so I didn't get real-time stats. And here I'm going to suppress just the real-time stats on the second insert. And I just have stats on load. There's no doubt real-time stats, I think, will result in fewer problems and better performance. Skewed data always has and always will be a challenge. There's absolutely no doubt that there's no substitute for collecting explicit stats correctly at the right time. So I think real-time stats is going to help. It's going to work hand in hand with high-frequency automatic stats collection. Think of this as just another stats maintenance window. It's a batch process, a PL/SQL procedure in DBMS stats. It's not enabled by default. You have to decide to turn it on. The key difference between this and the maintenance window that we're used to is it runs regularly. By default, every 15 minutes. It has a maximum runtime. So it runs continuously in background, but then restarts regularly. And what it does is it picks up the stay list tables and works through the list, starting with the stay list and working down that list. It's going to interact with real-time stats because as it collects stats explicitly, it's going to remove the real-time stats. I think it has some consequences and threats. You could see more cursor invalidation caused by collecting stats. You might see an increased pass overhead. You're going to get more statistics history turning up because every time you collect stats, the old stats are moved to the stats history. So you might see a bit more volume in there and a bit more purge. You can control it through some global statistics preferences. You can turn it on, you can set the interval, you can set the max runtime. And you can read back those preferences as well. And these are the default values: off, 1 hour runtime, 15-minute frequency. There's a table, a view called DBA Autostat Executions, and that will let you find out how this batch process has been performing. I ran it in background. I've been playing with the frequency in this test. Oh, let's go back. So you can see how long it ran for, how many tables it did. It always says failed 1 when it's completed, not quite sure why. I've never got it to time out. I don't have enough data on this system. And you can see this last one is in progress. So it says in progress 1. So I can see all of the executions and how long it took. Behavior of this procedure is driven by this sysstats target table. And it does things like preventing 2 processes collecting stats on the same table at the same time, I think through locking. You can see a timestamp when it started and finished. You've got this mathematical staleness function in the range plus minus 100, and it's based on the number of updates from the table monitoring and a couple of internal functions in DBMS stats. And it's a sort of quotient of staleness. You've got the object size, the object number. You've got some flags to say, is it in progress, complete? I think there's a timeout status. You can also get the SID and serial number of the stats collection process. You could perhaps track back into ASH data to see what that's up to. And you can also get the object and partition number that it's working on. So there's information about this batch that you can go and look up. You can see what it's been doing by joining sysstats targets back to obj$. And you can get a report of which objects it's been doing work on. And it's not particularly surprising that in an otherwise quiet database, it's spending most of its time on the AWR tables. So you can see it's looking at tables, table partitions, indexes, index partitions here. You can see what it's been collecting stats on. So These two features are 19C, engineered system only. Because I think they are aimed at the autonomous database. I think I'm pretty sure they'll apply well to if you ran, say, an ERP system like eBiz or PeopleSoft on an Exadata, it would be helpful. There's no question that collecting stats in appropriately and making sure they're up to date is generally good for performance. I would say, why not other platforms? If it's good for Exadata, then it's good for other non-Exadata databases. It's the same database, it's the same optimizer. If you set this parameter, underscore Exadata feature on true, you can get these features to work on any non-Exadata database. I've been able to reproduce this behavior on my own test VMs. Now, of course, you'd never do that in real life on a real data, anything other than a play database. But it does show that the feature is there in the ordinary database and it works. And that it's not a technical decision that it's not available on non-Exadata, it's a commercial decision. And I think that's a shame because I think a lot of people would otherwise benefit from it. So real-time stats, it's going to help regression by keeping some of the stats, row counts, min-max values up to date, but it's not going to do things that require scans of all the data. So you're not going to get histograms, you're not going to get up-to-date number of distinct values, and it's bolted on to table monitoring. So the marginal overhead is almost zero because table monitoring runs anyway. And I think the high frequency job is probably also beneficial because it's going to go after the objects that are stale sooner than waiting for the overnight maintenance window. I'm slightly concerned that if you had some really large tables, the job could get stuck, but that's also true then of the overnight maintenance window. And maybe you need to lock stats on these very large tables and handle them manually. But that's only that's a maybe at the moment. Okay, so that's a race through two of the three 19C new features. I'm going to talk about automatic statistics tomorrow. I see we've got some questions. Shall we deal with the questions? Real-time stats. No, I don't think the overhead of real-time stats is very high because they are built on top of table monitoring. So table monitoring is happening anyway. It's tracking the number of inserts, updates, and deletes. So I don't think that is a significant risk. There has to be some additional work, but it's not like it's executing DBMS stats recursively in the background every time you do an update. It's a really light in-memory sort of thing. So I don't think it's going to have a significant DML overhead, certainly not one that I've been able to measure. As for hybrid histograms, I'm not going to comment on that. I'm sorry. It's too much of a question. There is, by and large, in modern versions of Oracle, you want frequency or top-end histograms, and hybrid histograms open up a different set of questions. And I'm sorry, I'm not going to pick them up today. By and large, dynamic sampling is quite light, and very rarely does it have a significant impact. I have seen it have a significant parse impact when you have, say, I saw a GL reporting system where it had column in 1,000 values, and the dynamic sampling was done for each of the 1,000 values. Behind the scene, each term in the in becomes an or. It becomes column equals this, or column equals that, or column equals the other. So if you have 1,000 terms in the in clause, you have 1,000 or predicates, and it does the dynamic sampling for each value and adds it up. So in that kind of situation, if you've got certain kinds of SQL, I've seen dynamic sampling be a problem, but I think that's exceptional. I have no idea why column and table stats are different. All I can say is that, and I've tested this from 19.3 up to 19.8 and on version 20, the column stats turn up immediately. The table stats, you wait for the flush to happen. No idea, sorry. It's just something I've observed. I hope you can all see those questions. So there you are. We've reached the end. I think I'm inside time. Does anyone want to talk about anything else?
I think that is it. Yes, thank you, David, for being with Groundbreaker tour. I hope attendees will find this information useful and will use them in the real job. And I hope to see you also on a real conference, not only on webinar.
I hope so. I look forward to going back to real life conferences. I don't think it'll be for a while, but I hope it will happen one day.
Yes. Have a nice evening.
Thank you.